We're now going to take up a more powerful form of indexing, in fact, several different improvements. Our first is based on the idea that if the Jacquard similarity is very high, or equivalently the Jacquard distance is very low, then two strings representing sets of that Jacquard distance must have a symbol in common among their prefixes whose lengths are approximately the Jacquard distance times the length of the shortest string. For example, if we want strings that are 90% similar, that is Jacquard distance up to 0.1, then it suffices to look for a common symbol among the prefixes of the strings, where the prefix of a string is approximately the first 10% of that string. In general, if j is an upper bound on the Jacquard distance we will allow, then the prefix of a string of length L is the first floor of JL plus 1 positions of the string. We're going to build an index in which this string can be found using any of the symbols that appear in its prefix. The formal definition we're going to use repeatedly for a string's prefix is the first floor of JL plus 1 positions. Again, that's this. Where j is the upper limit we place on the Jacquard distance, and L is the length of the string. Let's start with a string of length L, represented by the orange bar. What's that? Suppose it has Jacquard distance j from some other string, but there's a long prefix of length E of the orange string that has no symbol in common with the purple string. If the Jacquard distance between the orange and purple strings is to be as low as possible, the two strings must agree exactly after that prefix. Put another way, the orange string consists of the prefix of symbols only it has, followed by the entire purple string exactly. In this situation, the Jacquard distance between the strings is E over L. You can check that by computing the sizes of the union, which is L, and the intersection, which is L minus E. Since these two strings are supposed to have Jacquard distance at most j, we must have j greater than or equal to E over L. Put another way, E can be as large as JL, but it can't be larger. Suppose we index the orange string under its first E plus 1 positions. That's the floor of JL plus 1 positions. We can take the floor since the number of positions we use has to be an integer. Then if the purple string is at distance at most j, it will have at least one of the symbols under which the orange string is indexed. The index structure can be thought of as a collection of buckets, one for each possible symbol that can appear in the strings. Those symbols are the members of the universal set from which all sets are drawn. Suppose we have a string S of length L. For each of the first floor of JL plus 1 symbols of S, say A, we'll put S in the bucket for A. A reasonable implementation is to store the pair AS as a key-value pair, where the key is the symbol A and the value is the string S. We could store all these in a B tree, for example, because that would make it very efficient to retrieve all the strings associated with a given symbol like A. We might store pointers to the string S rather than a copy of S itself, but that's a tricky implementation issue. Storing the strings themselves makes it more efficient to examine all the strings with a given symbol A without a lot of disk accesses, but on the other hand, storing pointers to a single copy of S will save space. Suppose we have set up this index and we want to find all those candidate strings that might be within Jacquard distance j from the given probe string S. Look at the symbols in each of the first floor of JL plus 1 positions of string S and examine all the strings in the buckets for each of these symbols. For each of these strings, we need to compute the actual Jacquard distance from the probe string S and report all those within distance j. Let's do an example of how this indexing and search for similar strings will work. Let j be the upper bound on Jacquard distance, say 0.2, and consider the string A, B, C, D, E, F. How long is its prefix? Well, first, L equals 6, since the string is obviously of length 6. JL is 1.2, that's 0.2 times 6. And JL plus 1 is 2.2. And the floor of 2.2 is, of course, 2. So we place A, B, C, D, E, F in the buckets for its first two symbols, that is, A and B. How about string A, C, D, F, G? Here L is 5, so JL is 1, and the floor of JL plus 1 is again 2. So it is indexed in the buckets for its first two symbols A and C. What about the string B, C, D, E? Well, L equals 4, and JL equals 0.8, and the floor of 0.8 plus 1 is just 1. Thus, we index B, C, D, E only under B. Now suppose we have a probe string, C, D, E, F. It is also of length 4, and the floor of JL plus 1 is 1. So we need to look only in the bucket for its first symbol, which is C, to explore for strings of Jacquard distance at most 0.2. Of the strings stored so far, only A, C, D, F, G, this, got indexed in the bucket for C. So that's the only candidate. Unfortunately, if we do the math, we find that the intersection of the sets A, C, D, F, G and the set C, D, E, F has size 3. That is, you've got C, D, and F in each one of these. And the union is of size 6. It's obviously got A, C, D, E, F, and G. And therefore, the Jacquard distance is 0.5, which is much too high.